All right, Precalc, we're working in lesson 8.4. We're talking about the binomial coefficients, and we're going to learn a lot today. So buckle your seatbelts and get ready. Our essential question is, how do you find the expansion of a binomial x plus y to an nth power? So let's talk about what that means. That's kind of like having x plus y to the third power, where in the past, you've known to do x plus y, x plus y, x plus y, where you'd probably FOIL these. X squared plus inners and outers would be 2xy, last terms would be y squared, and then you would have to distribute the x through all of them. X cubed, 2x squared y, xy squared, and then distribute the y through all of them. And yes, I know this is really boring. 2x. All right, so it would be 2xy squared plus y cubed. And then you would go ahead and I just add down, and you get x cubed plus 3x squared y plus 3xy squared plus y cubed. So that would be really great if all of the questions were that easy, but we are in Precalc, and Precalc isn't always left to things that are that easy. So sometimes we see like x plus 2 to the fifth power. And the answer is not just x to the fifth, 2 to the fifth, which is 32. You have to actually FOIL or multiply it all out. So we're going to learn how to do that today using what we call the binomial theorem. So we'll talk about the expansion of binomial theorem. You don't have to write all these notes down, but what I do want you to write down is the combination notes. Well, you don't even really have to write these down because I teach them differently. So this is saying n combination r, and the way that the books and formulas are written are n factorial over n minus r factorial times r factorial. So let's talk about what that would look like. If I had 5 combination 3, that would be 5 factorial, because the n is the first, this is the n. That would be 5 factorial on the top. And then I would take 5 minus 3, which is 2 factorial on the bottom. And then I would take r factorial, which is just my 3 is my r, so I'd take 3, 2, 1. And from here we would reduce, and I would continue to reduce, and you get 10. Now, this is a great formula and all, and I'm sure they don't teach it this way because there's no way to write a formula like this, but I teach it a little different. So here's what I tell my students. 5 combination 3, we're going to take 5 factorial 3 times, 5 times 4 times 3, and we're going to put that over 3 factorial, 3 times 2 times 1. So from here you see 3 and 3 cancel, 2 and 4 cancel, and my answer is still 10. So I'm sure you're going to say, does this work every time? If you don't trust me, you could do all of my problems in both ways, but trust me, I've tried it over and over and over and over and over again. Now, combination, NCR, is also seen as n over r in a parenthesis, so this is also a combination. So n over r in parentheses is the exact same thing as what we had. So let's go ahead and put some of these to practice. So 9 combination 2 is telling us 9 times 8, we're going to take 9 factorial 2 times, over 2 factorial. These cancel out to be 4. Answer is 36. Moving on. Remember, this is saying 11 combination 4. So we're taking 11 factorial 4 times, and that's going to be over 4 factorial, and hopefully you can see 4 times 2 is 8, 3 goes into 9 3 times, and 33 times 10 is 330. Now, there's a couple special case scenarios, so I'm going to teach you how to put this in your calculator. Okay, we do work with a TI-84 in here. If you push the button Math and scroll to the right using the gray keys, you'll see a PRB, which is probability. And at number 3, you're going to see NCR. Now, if you have a newer calculator, it's going to pop up like this, where you can just put the numbers in. If you have an older calculator, you're going to have to put the 8 in, do all these steps, and then put the 0 in. But 8 combination 0 and 5 combination 5 are both special cases. So if you actually put them into the formula, they both end up being 1. All right, there are 2 other scenarios. 14 combination 1. Again, it's a special scenario. This is just equal to 14. And 14 combination 13 is also equal to 14. My next video will be about the binomial expansion.